Next up, we'll cover temperature and moisture. First, we'll study humidity and dew point and why these are important to pilots. Water evaporates into the air. Water vapor is in most cases invisible, like oxygen and other gases that make up our atmosphere. The amount of water vapor in the air is expressed as relative humidity and as the dew point. Well, relative humidity relates to the actual water vapor that is or could be present in the atmosphere. Now, here is a weather fact. Relative humidity, by definition, is relative. Relative humidity relates to the actual water vapor to that which could be present. This graphic shows how relative humidity works. Here we have 3 containers each filled with air. At a lower temperature, you can only pack in so much water or water vapor, in this case shown by the blue specks. As the temperature increases, you can see the container, same size, we can pack in a little bit more water vapor, and as the temperature becomes very warm, we can substantially increase the amount of water vapor that can fit into a parcel of air. Another weather fact, the dew point is that temperature to which air has to be cooled to become saturated by water vapor already present in the air. Now check this out. Here are 3 examples with the dew point at 37 degrees Fahrenheit with a temperature of 55 degrees Fahrenheit and a dew point of 37 degrees. You can see a nice wide dew point spread with a relative humidity of about 50%. Now for this parcel of air, we can still pack in some more water vapor at this temperature. This is actual water vapor present. This is how much more we can hold. We can still pack in another 50% of water vapor at this temperature. Now, as we cool our air parcel down to 44 degrees Fahrenheit, same size container, but now we're at 75% relative humidity. Now, as we cool that air mass even more, we take the air mass down to the dew point temperature. They're both 37 degrees. It's saturated. Some type of cloud, precipitation, or condensation is going to occur. Our parcel of atmosphere is saturated with water vapor. The conclusion is that warm air has the capacity to hold more water vapor than cooler air. Now, here's a little weather wisdom. The temperature and dew point spread is very important in anticipating fog. As the temperature and dew point spread decreases, or comes closer together, that relative humidity is going to increase at 100% and fog will form. Now, pilots should be aware when the dew point temperature spread is less than 5 degrees, anticipate such an event as fog. Here are more weather facts. Water vapor is always present in the atmosphere and can be found in one of 3 states. It can be a gas, a liquid, or a solid. At 100% humidity, fog will form. As water changes from one state to another, an exchange of heat or energy occurs. Energy is contained in latent heat. A change of state is the process of latent heat exchange. A change of state by vaporization, condensation, sublimation, melting, and freezing is called a change through the process of latent heat exchange. As water changes from one state to another, an exchange of heat occurs and energy is gained and released. Now, here are the states of water. Here is water in a gaseous form. It's in a cloud. Through condensation, energy can be released to make a change by going from a gas into a liquid. Still releasing more energy through freezing, it becomes a solid like a snowflake. Or it can sublimate directly, releasing energy to change into a snowflake. Here is the reverse effect. It can also gain energy through latent heat exchange by changing from a solid to a liquid, by melting, and then from a liquid through evaporation into a gas, or it can directly sublimate back to a gas. Heat is always gained or lost through a change of state.